So hi guys, welcome you to the very important session on black box testing techniques. Now we are going to deal with black box testing techniques. In that, let's start with boundary value analysis. So what is boundary value analysis and how does it work? So boundary value analysis. So as its a name says, testing at the boundaries. Boundary value analysis. So let me explain you the clear picture of boundary value analysis here. So what is boundary value analysis? It's a black box testing techniques. So where to use boundary value analysis? So this boundary value analysis, we can call it as a BVA also, boundary value analysis. Now, so where to use this boundary value analysis? When your input, in terms of range or size, in terms of input in range or size, like 14 to 16, 20 to 30, 4 to 16, or size 5, 10, 15, 60, 40. So if your input is in terms of range or size, we'll be using boundary value analysis as a technique to derive the best possible ways. Okay, yes. So when we'll be using whenever your input in terms of range or size. So what does BVA says? The BVA says that there are possibility of errors. There are possibility of errors in and around the boundary conditions. There are possibility of errors in and around the boundary conditions. So if you know that there are possibility of errors in and around the boundary conditions, so what we need to do? We need to test the boundaries. As simple as that. Whenever you know that there are possibility of errors in and around the boundary conditions, so try to test the boundaries. So try to test the boundaries. So that is what boundary value analysis is. See here, it's a proven theory. It's coming from ages. So whenever you know that there are possibility of errors in and around the boundary condition, so just try to check the boundary levels. As simple as that. Yes. Now let's go ahead and let's discuss how to test at the boundary levels in and around the boundary conditions. In and around the boundary. Now, so whenever your input is in terms of range or size, we'll be using boundary value analysis. Boundary value analysis states that there are possibility of errors in and around the boundary conditions. So if you know that there are errors in and around the boundary conditions, so just test in and around the boundary condition, as simple as that. That is what your boundary value analysis is. Now, let us take an example and let's go ahead. Now, as discussed earlier, let's assume that we have an age box, age edit box. We have discussed this earlier. Now this age edit box will take age in between 18 to 80 according to the requirements. This age edit box will take only the values 18 to 80. So in this, so I have a minimum and maximum range. So minimum range I can call it as 18 and the maximum range will be 80. So what's your BVA say? Test in and around the boundary conditions. So what does in and around the boundary conditions means? Either way of minimum and maximum. That is nothing but minimum. We need to test with minimum. Minimum minus 1, minimum plus 1. In and around. In and around. Minimum represents in, around, minus 1 and plus 1. Maximum, maximum minus 1, maximum plus 1. So you need to test with this 6 possible ways. So what is minimum here? So minimum is 18. Is this valid? Yes. According to the requirements, it's valid. Minimum minus 1, it's 17. Yes. According to the requirements, it is invalid. We don't know how the application behaves. This is what? Just according to the requirements. Minimum plus 1, 19. This is valid. Maximum, maximum 80. Even this is also valid according to the requirements. Maximum minus 1, What is maximum minus 179? Even this is also valid. Maximum plus 1. It's 81. This is invalid. So whenever we derive a data using this technique, we are going to get few valid and invalid data. So let us write the test data here. So what is valid test data, guys? Here the data which is used to test an application with a positive flow. So whenever we are trying to test an application, we need to test it with both ways, with the valid data and with invalid data. Whenever we provide valid data to the system should accept it. That is what we need to expect it. Whenever we provide invalid data to the system should reject it. That is what we need to expect from the system. Whenever valid data is accepted and invalid data is rejected, then application is working good. So we need to test an application where there is a possibility. We need to test it with valid and invalid data to make sure that application accepts the valid data and it rejects the invalid data. Okay. Now, so what is valid data here? 18, 19, 80 and 79. This is the valid data, and we have invalid data too, like 79 and 17, 17 and 79. Yes. So whenever we provide this valid data to the system, system should accept it. Whenever we provide invalid data to the system should reject it. When it is accepting this valid data and when it's rejecting this invalid data, then application is working good. So rather than testing from 0 to 99, we have tested from 18, 19, 80 and 79. These 4 possible ways will be tested, expecting that system should accept it. And 2 possible ways will be tested, 17 and 79, expecting that system should reject it. Clear? Yes. So this is what the BVA is. Let's assume that whether it's really work. Yes. Let's have a trial on this. Let's assume that 18 to 18 is a requirement. Right? 18 to 80 is a requirement. Let's assume that developer has misunderstood the requirement and he has developed an application such a way that it takes 16 to 80. Rather than taking from 18 to 80, now it starts taking from 16 to 80. It takes from 16 now. Let's assume that we have an age box. Rather than taking from 18, now it takes from 16. According to the requirements, it should take as 18. But this developer has misunderstood the requirement and developed such a way that it takes from 16 to 80. Now, so whenever we provide the valid data, we have feeded 18 to the system and we have tested it. It's working great. It's in a range, 19 range, 18 accepted, 79 accepted. Everything is fine. But whenever we provide a 17 to the system, according to the expectation, 17 should be rejected. But system started accepting it. Why? Because this developer has developed like everything which is in a range 16 to 18 should be accepted. So 16 to 18 in this range, 17 is falling in that range. So system obviously will accept that. So according to our expectation, system should reject it, but system is accepting that. So there is a deviation. So something went wrong, report it to the developer. Clear? So whenever we tested the boundaries, there are a lot of chances that we can catch our errors. But this works only if your input is in terms of range or size. This is what we'll call it as a boundary value analysis. So we'll go ahead and we'll take one more example now. Let's go ahead. Now let's assume that there is a name edit box. Now, name edit box. And this takes, according to the requirements, this name edit box will take data from 4 to 8 characters. 4 to 8 characters. This is the limitations. It takes the data from 4 to 8 characters, but there is no limitation in it. It takes all the characters, all characters. It may be special characters, spaces, alpha, numeric, everything. We have no limitations on the type of character as if now. It takes 4 to 18 characters. That is the only thing actually what we need to deal with. Okay. Now 4 to 8 characters. So let's try to derive the BVA for it. So it's a range. So what is the minimum range? Is 4. So what is the maximum range? It's 8. So let's perform the boundary value analysis. BVA, boundary value analysis. So what is minimum? 4. Obviously it's a valid range. Minimum minus 1, that's 3. It's invalid. Minimum plus 1, it's 5. This is valid. Maximum is 8. Valid. Maximum minus 1. Maximum minus 1. 7. Invalid. Maximum plus 1. 9. 9 is invalid. Maximum minus 1 is valid. This is what valid is. So we got some valid and invalid data here. So let's derive the test data. Here bit tricky. Test data. The data which is used to test an application. If I say test data, that is nothing but the data which is used to test an application. So here what is valid data and what is invalid data? So a lot of people do think that valid is something 4, 3, 5. Sorry, 4, 5, 8 and 7 are valid. Invalid are 3 and 9. That's not. So valid data, valid tested data is 4 characters. This is valid data. 5 characters. My name, Kiran. 8 characters. 7 characters. This is the valid data. What is invalid data? Because I am saying it's a 4 to 8 characters. It's not like a range what the example what we have done earlier. So here the valid data, the data which is used to test an application should be like this. So what is invalid data? 3 characters and 9 characters. As simple as it. As simple as it. So this is valid data and this is invalid data. So whenever we are trying to test an application this with valid data, system should accept it. And whenever we provide this invalid data to the system should reject it. Whenever system is accepting this valid data and whenever system is rejecting this invalid data, then I can say that my application is working good. Now straight away question to you guys, just try to attend it. So have provided a invalid data to the system. Invalid data to the system. I know that it's a invalid. I'm expecting that system should accept it. System should, sorry, have provided invalid data to the system and I am expecting that system should reject it. And as a tester, you have provided the invalid data to the system and system has rejected it. So what's the test case? Whether it is passed or failed? Think once. You have expected it as a reject, it should be rejected, and at the final it has rejected. So obviously it's a passed test case. Why? Because the expectation and the actual are meeting. You mean you have intended and you have expected that should be rejected and it is really getting rejected. So obviously expectation and actual are one and the same. So that is the reason that particular incident is passed. This is what basically what BVA is. Now we'll go a bit in depth to the BVA concept. Some cases they may not give you BVA directly. They may not give you a range directly. In that case, you need to derive the range and you need to perform the best possible ways. Okay, got the point? So rather than testing with all possible ways, I am picking up the combinations and I'm trying to make the testing easy, right? Okay, now let's think a very interesting one. Let's assume that there is a mobile number edit box in a user registration box. Mobile number edit box. Now it has a limitations like this. The mobile number edit box should be 10 digits. It should be just 10 digits. That's it. Not more than 10. Not less than 10. Means even the 9 or 11, it will not accept. Only 10 numerical values should be there in the mobile number edit box, and one more condition, it should start with 9. So what is minimum and max is maximum? I'm repeating it. I want a minimum 10 digits number which is starting with the 9. I want the lowest 9 digits number. Sorry, I want the lowest 10 digits number which is starting with 9. Lot of people do say that minimum is 9 and maximum is 10. Have observed it. But 9, yes, it is starting with the 9, but it is not 10 characters. So it's not the thing. 10, it is neither starts with the 9 nor it's starting with the 9. Right? Yes. So this is not the answer. Think literally. The conditions are like this. It should be 10 digits and it should start with 9. So I want a 10 digits number which is starting with the 9, and that should be a minimum. So obviously this is the answer. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here it has a 10 digits. It is satisfying first condition. And which is starting with the 9. Yes, it is starting with a 9. And moreover, this is the minimum number. There is no other minimum number than this which has a 10 digits in it and which is lower than this. And what is the maximum? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a 10 digits which is starting with 9. This is a maximum 10 digits number which is starting with a 9. So after that, you know, minimum, minimum minus 1, minimum plus 1, maximum, maximum plus 1. That we can go ahead and you can do it. Okay, so in general, if you want, so minimum, minimum minus 1, minimum plus 1, maximum, maximum minus 1, maximum plus 1 will be taken. Okay, so maximum minus 1, it's optional. If you want, you can skip this. And minimum plus 1 is also optional. If you want, you can skip this. You can go ahead with minimum, minimum minus 1, maximum, maximum plus 1. You can skip maximum plus 1, minimum minus 1 if you want to much more optimize it, but I am not going to recommend it. In some books, or if you watch online, there are some videos and some notes saying that minimum, minimum minus 1, maximum, maximum plus 1 is sufficient for the boundary value analysis. But still, we have added two things, minimum minus 1 and what are that, minimum plus 1 and maximum minus 1. You can go ahead with this. Clear? So this is what general thing is, but if you want to skip, you can skip minimum plus 1 and minimum, maximum minus 1 also. Okay, so in my way of explanation, you will be getting six test data. In some cases you may get 2 valid data and 2 invalid data. That's it. So if you skip minimum plus 1 and minimum minus 1, there are chances that you'll be getting 2 valid and 2 invalid. That's it. Clear? So either way you can follow it, but follow the way what I have explained you. Clear? So we'll be getting 6 possible ways, 4 valid and 2 invalid. So this is what boundary value analysis is. When there is input in terms of range or size, we'll be coming and we'll be deriving this data. We are going to check at the boundaries. Why? Because testing at the boundaries will really help you to optimize a test. This is what the boundary value analysis is. It has some limitations, like data type will not be carried out using boundary value analysis. If you want to do a data type like alphanumeric 4 to 16 characters, it is 4 to 16 characters can be done using BVA. But what about alphanumeric? If it is an alphanumeric 4 to 16 characters, alphanumeric cannot be carried out using BVA. It only limited for the range. So if it is a data type, we need to handle it using ECP, equivalence class partition. Now in the next slide, we'll be having a look on combination of BVA and ECP, and we'll be trying to derive the test data